Hello students, welcome to the class of mathematics by Indefinite. Now today is the third lecture related to indefinite integrals. Some problems were left in the second lecture related to substitution method. So I am taking here. Uh, I was clarified what is the substitution method and how we can solve the questions through the substitution method easily. Now today I am taking some problems. As you have already studied the integration of sin x, you have studied that is minus cos x, and the integration of cos x was sin x. But the next four trigonometric ratios like tan x, cot x, secant, secant of x, cosecant of x, like this. What are the integrations of these functions? Tan x, cot x, sec x, and cosec x. Because we are not getting the derivative of a simple function that is 10x. So there is no formula of integration of 10x up to now. But today we are going to derive the formula of integration of 10x, cot x, sec x, and cosec x. So first of all I am taking the 10x. Integration of 10x. So we can write 10x as sin x divided by cos x, and if we take cos x as t, then the derivative of cos x is minus sin x dx, it is equals to dt. Now substitute these values, then we get, now sin x dx is minus dt because minus sin x dx is equals to dt. So in place of sin x dx we can write minus of dt, and cos x is t. So here we can write negative of 1 upon t dt. Integration of 1 upon x with respect to x, that is log of mod of x. So here it will be log of mod of t plus c. Now place the value of t, it is minus log cos x. So this is the integration of 10x. Also we can change this as, if we take this negative sign, so we can write log of 1 upon cos x using the property of logarithm. So it can be written as log of sec x. So this is the formula of integration of 10x. So by substitution method we can obtain the formula of integration for 10x, cot x, sec x, and cos x. So cot x, I am taking the second function, that is cot x, integration of cot x. As we have obtained the formula for 10x, in the same way cot x can be written as cos x divided by sin x. Now here if we substitute sin x is equals to t, then its derivative cos x dx, it will be dt. Then it becomes dt upon t. Its integration is log of mod of t plus c, and place the value of t is sin x. So the integration of cot x is log of sin x. So now we can remove this question mark because now we have the formula. It is log of sec x plus c, and this is log of sin x plus c. Now we have to find formula for integration of sec x. Now to find the integration of sec x, because there is only one function, there is a trick. You can write sec x dx, then multiply by sec x plus 10x in the numerator and denominator both. Now, in the numerator, if we open the bracket, then we get sec square x plus sec x into 10x dx divided by sec x plus 10x. Now let sec x plus 10x, which is the denominator, take this term as t. Consider sec x plus 10x, which is given in the denominator, as t. Then the derivative of sec x is sec x into 10x, and derivative of 10x is sec square x dx, it is equals to dt. Now you can see this sec x 10x plus sec square x dx, the whole quantity is given in the numerator. So we can write this is dt and sec x plus 10x is t. So it is equals to log of t plus c. The value of t is sec x plus 10x. So place here is sec x plus 10x. So this is the formula for the integration of sec x. Once again, we have the formula for the integration of sec x, that is log of sec x plus 10x plus c. In the same way, we have to find the integration of cos x. Now this one, do yourself. So the trigonometric functions which do not have the formula of integration, today we have obtained the formula for these functions. Now we have the formula of all the trigonometric ratios. Now learn these formulas, include these in the formula list. Now I am taking some more questions related to the substitution method. Before that, I want to discuss one thing. That a function is f of ax plus b. The integration is capital F of x plus b. Sorry. Uh, yes. We have the integration of fx, small fx, is capital F of x. Then what will be the integration of f of ax plus b? So we know, or we can say it is given, that the integration of f of x dx is capital Fx, and we have to find the integration of f of ax plus b. Then we can use the substitution method. Let x plus b is equals to t, x plus b is equals to t. Then its derivative will be a dx plus 0 is equals to dt. Then the dx is equals to 1 upon a dt. If we substitute this in this integration, we get f of t 1 upon a dt. So 1 upon a is a constant, take it outside the integration, and because the integration of fx dx is capital Fx, so here it will be capital F of t plus constant of integration. So it is 1 upon a f of ax plus b. What is the conclusion? If a linear function is given like ax plus b, and if we replace this function by a single variable, then we can find the integration. But in that integration, the coefficient of x will come in the denominator, and there is no effect of the constant term, that is b. Now, how we can use this formula? Just like we have integration of x square dx, that is x cube upon 3 plus c, you know very well. But if in the question it is given the ax plus b whole square, find the integration. Then ax plus b, suppose this is t, then t square, then we are getting the same result, that t cube upon 3 means ax plus b cube upon 3. But it is not correct, it is incomplete. We have to write the coefficient of x in the denominator. So we have to multiply by 1 upon a. So the result will be ax plus b cube divided by 3a. Similarly, another example, like you know very well that integration of sin x is minus cos x. But if it is given integration of sine 3x plus 5, then what will be the integration? The integration of sin x is minus cos x. So suppose this is a new variable 3x plus 5, we can take here capital X, then its integration will be minus cos x, that is 3x plus 5. But the coefficient of x is 3, so we have to write 3 in the denominator. This is the final answer. So always remember this thing, there is no effect of this constant term, but the coefficient of x, whatever is given, it will come in the denominator of that function in the integration. Is it clear? I am taking some more questions. Now, one question is here: integration of 1 upon 1 minus 10x. So it can be written as 1 upon 1 minus sin x upon cos x, and simplifying we get cos x upon cos x minus sin x. Is it clear? Okay. Now we can write this cos x as 2 cos x multiplying by 2 in the numerator and dividing by 2 in the denominator, cos x minus sin x dx. Now this cos x can be written as cos x plus sin x plus cos x minus sin x. Adding sin x and subtracting sin x. Here we have added sin x and here we subtracted sin x, and this cos x and cos x, that is 2 cos x. So we can write this expression like this. Now separate like this: cos x plus sin x divided by cos x minus sin x dx plus 1 by 2 cos x minus sin x divided by cos x minus sin x dx. We have separated these two functions. One is cos x plus sin x, another is cos x minus sin x, and 1 upon 2 is with the both terms. Now, in the second term, cos x minus sin x divided by cos x minus sin x, these terms are cancelled out. We get only 1. And there is no problem in the integration of this term. But in the first term, we have to use substitution method. Okay. Now, in the first term, let cos x minus sin x as t, then the derivative of cos x is minus sin x, and derivative of sin x is cos x dx equals to dt. Taking negative sign as common, then we get sin x plus cos x dx equals to minus dt. So in this way we can write it 1 by 2 cos x plus sin x dx is minus dt upon t plus 1 by 2, the integration of 1 with respect to x, that is x, constant of integration c, and here it will be minus sign outside. 1 upon t, integration of 1 upon t is log of mod of t, plus it is 1 by 2x plus c. Now replace this t by the value of t. T was equal to cos x minus sin x, so it is equals to log of cos x minus sin x within mod plus 1 upon 2x plus c. So this is the answer. So here we have used this trick how to break the function. Like cos x, we have written this cos x as 2 cos x and then 2 cos x again split in this way by adding plus sin x and minus sin x. So by practice you can remember these tricks and you can use these tricks. Now I am taking one more question. The question is, find the integral of x cube sine of tan inverse x raised to the power 4 divided by 1 plus x raised to the power 8. This question is looking very difficult, but it is not so. Observe the question. Whatever given in the angle of sine, that is tan inverse x raised to the power 4, this is a composite function. If we take tan inverse x raised to the power 4 as t, you will get a simple function sine t, and the derivative of tan inverse x raised to the power 4, we will get all other terms. Try to find. Let tan inverse x raised to the power 4 is equals to t. Substitute this value. And what is the derivative of tan inverse x raised to the power 4? That is 1 upon 1 plus x raised to the power 4 whole square. This is the derivative of tan inverse x. 1 upon 1 plus x square. But in place of x, we have x raised to the power 4. So, again, the derivative of x raised to the power 4 is 4 times x cube dx. And here it is dt. So, the derivative of tan inverse x raised to the power 4 is 1 upon 1 plus x raised to the power 4 square into 4 times x cube dx, that is equals to dt. So, here we can write x cube dx upon 1 plus x raised to the power 8 is equals to dt. So, in this question, this x cube, this term along with this term, this whole quantity, 1 upon 4 is there, this 4 will come here 1 upon 4 dt. So, in place of this quantity x cube 1 plus x raised to the power 8 in the denominator and dx, we can write 1 upon 4 dt, and this quantity sine tan inverse x raised to the power 4, it will be sine t. So now our question is changed. It is sine of t into 1 by 4 dt. That is a very simple function. 1 upon 4 take outside the integration, it is a constant. The sine t dt. What is the integration of sine t? No, it is minus cos t plus constant of integration. It is minus 1 by 4 cos, and the value of t is tan inverse x raised to the power 4. So we can write here tan inverse x raised to the power 4 plus c. So this is the integration of this function. So now practice the questions, solve all the questions of the exercise and more questions from other refresher books. Also you can use the exemplar planner of NCERT, that is a very good book for the practice. Okay, thank you. In the next chapter, in the next lecture, I will take the new method to solve the questions, that the method of by parts, how to solve the questions by integration by parts. And also I will take some questions of trigonometric using the trigonometric identities, how to integrate the functions using the trigonometric identity. Okay, thank you.